Hello, everyone. Welcome to my talk at the Microsoft JDConf 2022. First of all, I'd like to thank the program committee, the organizers, for supporting the speakers and giving me this opportunity to present at this conference. My topic today is on event-driven change data capture pattern using Apache Pulsar. My name is Mary Grigleski. I'm a streaming developer advocate at DataStax. And here's my Twitter handle. So, a bit about myself first. I'm a senior developer advocate at DataStax. And before this, I was a Java developer advocate at IBM for about 3.5 years. And for me, I'm relatively new at DataStax too, about 7 weeks so far. So I'm actually working on the streaming product at DataStax, which the streaming product supports the main product at DataStax, which is a managed Cassandra cloud platform, as well as the Cassandra, the DataStax enterprise system. Also, as such, DataStax specializes in big data, in data management, NoSQL, very robust systems, and also suited now in the cloud native times too. So that's my area. And then at IBM too, I worked on also primarily all the open source libraries, such as Jakarta EE, the Java Enterprise Edition, working on Microprofile, Eclipse Foundation Microprofile project, and also Open Liberty, which is an IBM open source project. And then also the OpenShift, the Red Hat OpenShift orchestration platform, Kubernetes-based platform. So I'm primarily working with cloud, DevOps, all of these things. And also, too, I did advocacy for reactive systems, so I'm familiar with that. And event-driven systems are really my area, my cup of tea. Streaming, distributed systems is my passion. And I also have spent a few months, too, working on MQTT, the IoT messaging protocol, too. Now, I'm also a Java champion and also a community builder. I'm currently the president of the Chicago Java Users Group. I'm also a co-organizer with several meetup groups for IBM in Chicago too. So that's about me. And also on the right-hand side, those are how you can get a hold of me. Follow me on Twitter, my LinkedIn profile ID, and also GitHub ID, and also on Twitch. I also have a Twitch stream. So all of this information I'll share with you towards the end of this presentation as well. Here's the agenda for today. First of all, why change data capture? Acronym CDC. And it's supposed to, is serving all of the data sources. And then what was there before CDC? And then we'll also move on to take a look into the components of a CDC system. And then let's also try to understand what are the requirements for a modern CDC system. And then from there, I'll introduce you to Apache Pulsar, which is, positioned very well to be, this modern unifying messaging and streaming platform that supports CDC on Astra DB, the managed Cassandra cloud platform. And then I'll show you a quick demo of the Astra DB as well. So first of all, why change data capture? What is CDC for? Its mission is to serve data sources such as databases, data lakes, or data warehouses. So as such too, it deals with huge amounts of data, big volumes of data too. So what it does is that it detects, it captures, then transforms, and propagates those changes in the state of these data, from the data source, data sources, and then essentially propagates them down to the downstream data system. So that's essentially, to sum up, that's what CDC is for. And here's a picture to illustrate it. I think this is just a very simplified one, but I feel that a picture is worth 1,000 words. So let's take a look. First of all, you have your data source right from the left hand, like a flow from left to the right side. First, you see that there's a soldier looking at through the binocular. It's like detecting its job, right? It's like a soldier detecting changes. CDC will be detecting the changes. some way the mechanism can be any way. It doesn't have to be event-driven or asynchronous. It can be database or it can be the other way too. So there are many different ways of doing it. But the concept is you do need to detect those changes. And then you want to, once there are changes that's been detected, then you do want to essentially capture it, right? Extract. And then from there, you want to perform some transformation on it. It may or may not be necessary, but I think a lot of times we may need it because maybe the source systems, the data types aren't the same as the target system. So you do need to massage the data before you send it over to the target data system. And then lastly, right, it is the propagation. You want to propagate those changes into your downstream data system. So that's a very simplified look at it. Now, what was there before CDC, you may ask? ETL, extract, and transform and load that process. Now, especially too, if you have worked in perhaps more of the mainframe or older systems too, ETL is very commonplace. Now, that's actually some disadvantages. Now, while it does its job well, but ETL very often is all like batch processing. You're processing the data that you've been collecting during the day. And then at the end of the day, at nighttime when there could be less processing, then that's when you do the ETL, extract, right, and transform and load. So that's kind of what CDC is trying to do too, is ETL, but in a modern fashion. The disadvantages too of ETL is slow. It's really very synchronous too. The way it does its processing is pretty much, you request or you batch it up together and you process, you wait for one thing to end before going on to the other. It's pretty much kind of blocking type of operations. And the processing will be in batches too. So as you can see, if you have limited bandwidth, that may be an issue if you have a large data set at the end of the day. So that's something that you need to be aware of if you're doing ETL for a large data set. And I remember myself doing ETL, and sometimes you have to break up your files into many chunks by hand. Back then, right, in probably the early 2000s or late 1990s, right? And you have to write a lot of code in scripting and break up all your files, in chunks and process them. So we know it isn't as kind of ideal kind of tooling. And not only that, right, the process itself, the setup tends to be quite heavy too. As I mentioned to you, without the modern tools, you need to write a lot of script perhaps to kind of do, essentially what it is doing now, sharding, maybe like splitting things up, partitioning, all of these things, you have to do it kind of manually. So it can be heavy, the processing, the setup side. And then, also too, sometimes the ETL tools themselves can be very expensive too. And it's not able to keep up with the times. So now then, let's take a look at the components of the CDC system. As we can tell right now, CDC, it shares the same concept as ETL too. But what make up a CDC system then? So essentially, right, is the change detection, and then change capture, and then change propagation. So these are kind of like the three primary components of a CDC system, much like the ETL, extract, right? It's kind of, slightly different. Extract, transform is sort of like detection, right? And capture kind of together. And then the propagation is to load it, essentially. And then the transform is kind of implicit, I suppose, in this CDC system. Okay, so now then let's take a look into a transaction log-based CDC. So in other words, too, you don't necessarily have to use an event-driven system. However, let's try to understand what would happen if you're using transactions to do it, right? So take for this example over here, you've got, some update to a table on the same field by two separate clients. So client 1 set X to 1, client 2 set X to 2. Now you apply your CDC process. It detects the changes, and then what it does is that it captures them, right? So if you capture them, then it gets logged onto your transaction log file. So over here, if you take a look into this file itself, you see that, it's in this case too, is the newest one goes on the top. So you can see that, okay, The update, first of all, if you go down, the bottom one is update the table, set x equals 1. And that's the first one that gets in. The second one that gets in, updating the same thing, update the table, set x equals 2. So in this case, then both set of changes will be loaded, right? And also get essentially propagated over, being applied to your target data systems too. But you'll notice that at the end, it will apply both changes, but the state will then be x2, x equals 2, because x equals 2, when you set that, that's the newest operation, so that will kind of overwrite what was before. So this is how kind of simplified way of understanding a log-based CDC. Now, let's now then take a look at the requirements for a modern CDC system. Okay, first of all, what is the definition of a modern system? Essentially, we want it to be cloud native, right? Cloud native is lightweight, also kind of a serverless, kind of implicitly meaning is serverless too, because as such too, it's also like microservices. You can actually be doing things, using that. Very lightweight. All cloud native is containers driven, orchestrated by container orchestrator. All of these things, and all of these other things cloud native, right? And then also systems have to be very responsive. The latency should be very low. That's an important thing. And then also very scalable too, right? And if you get more requests coming in, you want your system to be able to scale really well, right? And more processors get spun up to handle all of the requests. And also too, as such, right? And reactive systems, there's concept of back pressure too. You can have many, requests coming in, right, being sent, but the consuming side can be slow too. So there's got to be back pressure control mechanism, so then you don't choke your broker essentially, right? And so the producer is not able, or producing too much, then your consumer not able to get caught up. But you want to have some sort of back pressure mechanism, scalability involved, and then also resiliency, right? So if there are any downtime, right, you cannot tolerate it. It needs to be able to bounce back, right? Very resilient. Recoverability, resiliency. That's kind of what's kind of encompassed inside the definition of a modern system in the computing world. Now, let's then take a look too. Looking at how about, now we're dealing with data. Let's transmit these data as messages, right? And so what would be needed, right, is in kind of a messaging kind of system, right? So first and foremost, reliability and resiliency, like I talk about too, the requirement of a modern system. QoS, right, quality of service, that kind of guarantee delivery. You want to make sure that no messages get lost, and that's very expensive. You don't want that to happen. So quality of service kind of guarantee the message delivery. You can have quality of service 0, which is like, okay, fire and forget, you don't need acknowledgement, or quality of service 1, which is like, it has to be at least 1 or more. It can accept duplicate messages too. And then there's also quality of service 2, which is exactly 1 and no more, no less, like that. So those are reliability, quality of services type of requirement in messaging. And responsiveness, how can we achieve it, right? So think of it that way. We want a system that is lightweight, that can support asynchronous style of messaging. Asynchronous too, meaning that you send your messages and you go off, do something else and not sitting there to wait for it. That's very important, because then you don't tie up any resources. And also too, all of the components in your system has to be loosely coupled too. They don't kind of like too close to each other or too tightly coupled. Then it would be hard to do things if you can't break it up easily. It doesn't scale too well like that. So now then it leads into the next thing, scalability too, right? That's important for messages too. Essentially too, we want to have like a pub-sub type of kind of mechanism in your messaging, publish and a subscriber, and then with a serverless broker in between. So think of this broker as like a post office kind of thing. So then your publisher, right, or producer of these messages, go to the post office, go to your broker, and send the messages as client, producing client, as a producer client, send messages to your broker, And then the broker will then, according to the different settings, will kind of deliver it accordingly or retain it, whatever, all these things. And then on the subscribing side too, right? The subscriber too, likewise, right, will be subscribing to a topic, right? You produce to a topic. If I'm interested in it, my consumer will subscribe to that topic. So when the messages arrive, then the broker can deliver the messages to all those subscribers who are subscribed to this topic. And it helps with a lot of scalability too. If you have tons of messages coming in, or kind of like you have more kind of messages coming in, you can actually spin off components easier to handle this kind of situation. If you aren't too busy, you want to scale it down too. You don't want to waste any resources, especially in a cloud native environment, because every use of your resources costs money too. Okay, and then of course too with messaging, message ordering too is also very important too. You don't want, because of asynchronous nature, you can have different segments of your messages kind of arriving, all in out of order. But you need to have the mechanisms to make sure that the messages on the receiving side get kind of put back into this right order. Okay, so that's about that. Well, looking at all these, right? These all require a paradigm shift essentially. But how about it then let's take it to another level, event-driven approach. How about now then let me introduce you to Apache Pulsar. And what is Pulsar? Meet Pulsar. It is an open source project. It was initially created by Yahoo back in 2015 or so, and then Yahoo, because based on the fact that Yahoo was finding that other messaging systems, such as even Kafka, couldn't meet their needs because they already are adopting a lot of cloud computing. They realized that the scalability side may be an issue. So then also like geo-replication, all of these things. So Yahoo developed take ownership first, of this project, and then it contributed eventually to Apache Software Foundation in 2016, and very soon, even less than 2 years in 2018, it became a top-level project because of its capability as a unified messaging and streaming platform. It's got natively has this cloud-native design, from the ground up, right? It's cluster-based, multi-tenant, really kind of a set, all set for a cloud-native kind of environment too. And it's also got very simple client APIs that are in Java, for example, Java client, C#, Python, Go. You can have C++. There are also community contributions in Scala and Dart and other languages, Ruby as well, for example. It's essentially, too, it separates out the compute and the storage. So it makes the scalability aspect a lot more easier as things are not tightly coupled, right? Okay, and then also it's guarantee message delivery. Pulsar already has built-in mechanism to guarantee message delivery, right? And then it's also very lightweight. It also has what is called like Pulsar functions, a framework too, that allows you to develop certain first serverless functions to process data, and then helps you to build the pipeline and do message mediation, remediation, and transformation. And Pulsar too is a tiered storage offloads too. So basically it has built-in already mechanism to notice that if data as offload data, you want to offload data from the hot storage and then over to the cold long-term storage too. So all of these things are already built into Pulsar. So now let's take a bit more look into what is Pulsar. It is a unified distributed messaging and streaming platform. It's open source, right? And then I already talked about that, became a top-level Apache Foundation, Software Foundation project. And it's cloud native, right? It supports Kubernetes. You can do multi-cloud, on-prem, hybrid cloud too very easily. So if you can see too, there's just a couple of graphs too. I just thought I'd share with you the number of GitHub stars and contributors, and also active contributors have kept growing since it's been contributed to open source at Apache. So yeah, and to this day is all very popular. So who else is using Pulsar? So these are a list of companies that includes Yahoo, Comcast and Splunk, Verizon, right? Other Overstock. Yeah. And then brief history of Apache Pulsar. I think I already talked about it, but these are essentially the same slides. Yeah. So, and Pulsar component too, right? So first of all, in a messaging pops up kind of systems, you got a producer and also a consumer, right? As I mentioned to you, and that there's also earlier about the broker side is a serverless process, right? That handles incoming messages and message dispatching, communicates with the Pulsar configuration store and stores messages in bookkeeper instance. So that's another thing is that Pulsar offload all of these log storages to a different library, another Apache open source project called Bookkeeper, or there's a nickname Bookie too, and that's what it is. So Bookkeeper, its job is essentially doing accounting, doing bookkeeping. It has its own ledger, journal to kind of handle all of these things, which would otherwise be a heavy burden to Pulsar to manage that, right? So that makes a bit of a separation of concern, makes it this whole library a lot more lighter too. And then there's also Zookeeper that it uses for managing like metadata on that level too, and handles coordination tasks between Pulsar cluster. And Apache Pulsar is the design principle is that it's a tiered architecture design. Is a traditional multi-node architecture. And as you can see, right, you can have multiple brokers, it's all clustered, and distributed architecture that supports horizontal scaling. Partition topic abstraction, it makes complexity, it masks the complexity from the consumers, right? So there could be like common challenges in a cloud-native clustered environment, right? If you want to scale, it requires partition rebalancing. But this is, for example, this is one aspect of the strength of Pulsar is that it already knows how to handle rebalancing all of your partition accordingly if you're scaling up and down. And then tightly coupled persistence and message service capabilities, right, impose high cost on historical data, right? So those are kind of challenges that actually Pulsar has overcome too. The whole system, as you can see, the design from ground up is already very loosely kind of coupled and got this separation of concern type of approach. And then trade-offs too. Another challenge is trade-offs to support partition topics came at the expense of messaging semantics needed for use cases such as queuing, right? So actually, that's the thing too. With Pulsar too, it also supports queuing, in addition to support pops up too in all in the same system. So it's really like poised for the modern age. Design principle, we continue a little bit, but I just wanted to point out, right, what's the big deal, right? So essentially, it's fast, it's low impact, supports horizontal scaling, and it reduce costs. Broker is stateless, built-in load balancing, instantaneous scaling. It knows how to rebalance, all the partitions, zero impact disaster recovery. And the Bookie too. Now I won't go into all the details, but as you can see, it also supports a spec. It's called WAL. It's the write archive protocol too. And if you're familiar with that, it's actually very fast write. It separates out the write and the read to journals too. And a segment-centric data persistence via ledgers. And now, essentially, Apache Pulsar solves the problem of bolt-on, right? It's a really unified solution for PubSub, for queuing, for streaming, message mediation, and enrichment. So basically, too, if you already have systems that are running on-prem, say, Java, as such, too, Pulsar is written all in Java, too, but it supports client of different flavors, right? So Pulsar, for example, you have Kafka, you have JMS, you have the older MOM system running, RabbitMQ on-prem. You don't have to get rid of them if you don't want to. And essentially, Pulsar, you can add it sort of like bolt on and kind of on top and does its job. So think of Pulsar that can augment what you already have and really suited for the modern age. It's basically out-of-the-box capabilities include like cloud, on-prem, and hybrid, geo-replication, multi-region support, data lake integration, and much, much more. Now, enabling CDC, let's go back to the change data capture for the Astra DB. Astra DB is DataStax managed cloud, Cassandra cloud platform. And there's a change data capture feature already available now for Astra. But let's kind of first kind of take a look to is data, database table. Once you enable CDC for Astra, if there's anything, so what it does is that it's basically leveraging on the broker, the Pulsar broker, the PubSub kind of way of processing. That's how I leverage it to enable the CDC mechanism in Astra DB. So there's a streaming tenant, right? So in Apache Pulsar's term is that its tenant is essentially a unit where you kind of manage administrative unit to managing your streaming namespace and the tenants, essentially multi-tenants too. And I'll show you in a second, right, what it looks like. So it separates out their data topics and also log topics too. So I'll show that to you. And then there's also there's a streaming sink. So that's what it is, right? So there's a sink. Essentially, think of it. Okay, source. You do all these transformation, do all these things. It goes through, pops up. Your consumer gets it. You can transform it, and essentially, well, eventually, you can write it to a sink, deposit the result, and from there, it will just kind of be propagated to downstream targets, right? So, in other words, you can actually have different. You can write also your own connectors to connect to certain data sinks. But they are already ready-made, such as Elasticsearch. We have Elasticsearch Sync. We have Astra DB Sync, right, the Cassandra one. Google BigQuery, any Kafka Sync, MongoDB, right? There's JDBC driver for MongoDB, for SQL Server, Snowflake, all of these too. So that's just kind of shows you how it works, for CDC for Astra. And DataStax is really taking Pulsar 10 times farther, right? So we have different flavors of our product offerings too. Let me kind of take a look now. I won't repeat all of these things, but you can see too, Pulsar is like this unifying kind of capability. And Pulsar meets you where you are. We have Astra Streaming is a managed Pulsar. We'll give you $25 credit if you sign up with us, right? And then it's free things for you to explore. And it actually will last for quite some time too. And then there's also Luna Streaming, which is essentially the open source Pulsar. And if you want, you can use it as is, or if you want to purchase support too, you can too. And then if you want to go all open source, you can use the community-driven Pulsar too. DataStax Stream offerings, there were Astra Streaming, and right now it's coming soon, so please stay tuned, right? It's open source, open source foundation, right? And then Luna Streaming, again, is you host yourself. There's open source distribution. You can buy support, enterprise support, and it's free to use. It's available now. Okay, so we are still seeking early access participants for your Astra Streaming if you'd like, and let me know. Quick demo. This is our Astra DB. So if you go to astra.datastax.com, I'll give you the link towards the end, but you can quickly sign up. Oh, this one, I already created one, so I can just log on. But otherwise, you'll find that it's very painless too. If you first sign up, then you set up your token, and it's pretty much that's it. You come in and you see what you have. As you can see, I've already created my database and also defined my Pulsar stream too. So I'll just kind of quickly show it to you. But right now, because of the timing, I won't have time to kind of show you way too much. But as you can see, at this point though, just a bit mindful is that if you create the database in a certain region, make sure that your streaming, when you define your streaming, when you create your stream, that it matches the region as your database too. So that's a bit of a limitation for the time being. And also, if you want CDC, there are only certain regions that support CDC too. So you might want to check the documentation for it too. And I'll point that out to you also towards the end of this. So as you can see, I've already done this. And then with every Cassandra, you have a key space. It's already all defined. And I also have another, I've created my streaming tenant too. This one's already created, so I won't get into all the detail, but it's actually quite nice, as you can see, right? It lays out everything that you need, all the parameters. And then let's say I want to write a Java client. It gives you all of the information that you will need. How do you kind of do as a starter. You can do that, Maven, Gradle. How do you do a producer, right? The producer code, how do you send it, right? Set up connect, essentially connect to your broker and then send it, right? And then close it. Consumer is connect, and then consume is subscribe, right? And then close it when you after you receive. So yeah, please take a look, And of course too, I have to show you too, how do you enable CDC, right? So over here, if you go into here, you do need to go into your tenant. Where is it? You can go to here. On your database, there's a CDC over here. click the CDC and then click Enable CDC. And that's how you do it. Now, I've already done it, right? So I won't kind of add more. But if you do it, you'll find out that you can then pick the tenants that you want. Is it, all these other things. So, and as such, I believe that my time is up. So I will quickly go back to my slide and finish up. And where to go from here? These are all the links. I want to point out CDC for Astra DB that's contain all the documentation. And then CDC for Astra DB is here. And let's see. And oops. So sorry. And okay. Let me, sorry about that. And let me go back to my, here, okay. And then Astra DB, I want to point out to you that you are all invited to sign up for a free tier Astra account at this link and also this QR code if you want to quickly scan it. And if you want to get an additional $200 in credit, you can use this code, OpenSource200, and you'll get $200 credits too. And you do need to add your payment if you want to claim your credits, so the extra credit. Otherwise, the $25, it comes without you giving any of your credit card. And please follow my Twitch stream every Wednesday at 2 p.m. Central. Oops. And join us at the Pulsar neighborhood and also our meetup group too. With that, thank you so much. Really appreciate you joining me today. And please stay in touch with me. I'm also on Discord. I welcome any continuing conversation on Pulsar and streaming and event-driven libraries. Thank you.